Hey, happy Friday! We are going to be working in our packet quite a bit today, so you might as well grab math packet number 7 to get you started. If you don't have math packet number 7, you need to get math packet number 7. Come to school, get it. It's here for you. If you don't have it, just use the digital copy on Google Classroom. But turn to page 17 in your math packet today. That's where we're going to get started here. As you're flipping there, decomposing angles is what we're going to be talking about. Decomposed. Talked a lot about that word throughout the year. Decompose literally means to break down or break apart, right? So if I take an angle and I break it down into smaller pieces, right? Smaller angles that basically create that larger angle. So if I have like a 90-degree angle, I could break it down into a 50-degree angle and a 40-degree angle. Those two angles, when put together, compose or bring back together, rebuild together to create a 90-degree right angle. You're going to hear some vocabulary words today that are a little bit crazy, like complementary, supplementary. We'll be talking a lot about what those words mean, but we've already talked about decompose. Additive basically means like you're adding angles together, so they can be put together, additive. Sum is obviously the answer in an addition problem. So you have like add-n plus add-n equals sum. Angle, we know what that is. It's the amount of turn that two rays have in between. And then degree is what we measure angles in. It's the unit of measurement. And then complementary, supplementary, I guess you'll have to wait to find out. Now let me back up to what I had skipped over. What do you notice about this image? I want you to just take some time to think through what you are noticing. So one of the things that I notice is that there is a purple straight angle that measures exactly 180 degrees down on the bottom. But then I also see that this pink ray with the blue ray creates an angle that is a right angle. And I notice that because of the square corner here. It measures exactly 90 degrees. And then if you really want to get more specific, this blue ray with this purple ray creates an acute angle. This pink ray with this purple ray creates an acute angle. But there's actually even more angles than that. This purple ray with this blue ray is an obtuse angle. This pink ray with the purple ray is also an obtuse angle. What's also interesting is that if this is truly 180 degrees or half of a circle, this purple angle here that you see, the straight angle, then this angle right here that my mouse is hovering over, the pink and the purple ray, plus the right angle, plus the blue and the purple ray angle, so this acute angle plus the right angle plus this acute angle, will all equal 180 degrees, right? Because if you think about it, from here to here, plus here to here, plus here to here, well, look, that's half of a circle. That's 180 degrees. So if that's 90 degrees, right here, this section from here to here, that's the right angle. Well, that means that there's only 90 degrees left for this angle here and this angle here. So in other words, that 90 degrees can be split. And if I said that this angle here, the orange turn here and the orange turn here were the same, then that means that this has got to be 45 degrees, right? It's half of that 90-degree angle. And this is 45 degrees. If I told you that they were the same, right? 45 plus 45 is 90, plus 90 is 180 degrees. That takes you all the way to create a straight angle when it's all said and done. We're going to talk a lot more about that today. So your objective today is to be able to solve some problems that involve adding angles together. That's called additive angles, or decomposing angles is another way to think of it, because you can also use subtraction to find some of the unknown angles. So in the example that I just gave, I actually had to use subtraction. I knew that the whole thing was 180 degrees. I subtracted 90 from it because I knew that was right angle of 90, and I knew that here and here, when added together, would give me 90 degrees. And if I told you that both of them were the same, then that means I can split it in half, right? Cut it in half and have 45 and 45. That's the same number, right? Now, the only way to determine an angle's measurement is with a protractor. Is that true or false? To find the exact angle measurement. The answer to this is false. Yes, protractors are amazing tools. I have two in my hands right here. Super cool tools to help us find the exact measurement, but they're not the only way to find the exact measurement. And when I say exact measurement, I'm not talking anything related to guessing or estimating. Like, there's another way mathematically with numbers that you can calculate how many degrees an angle is. For example, going back to this picture, you didn't need a protractor there. You knew that this was exactly 90 degrees because it was given to you as 90 degrees. And then I knew that the whole entire purple angle was 180 degrees. And 45 plus 90 plus 45 gives me 180. So I didn't need a protractor to find the measurement of this angle right here that's acute, or this one right here, if I was told that both of them were the same angle measurement. Now, if I didn't know if this angle was smaller or larger than this one, it's not given to me, and I'm not telling you that, then yeah, I can't find the exact measurement then without a protractor. But depends on how much information is given to you, right? I gave you a lot of information that you could use to help calculate. That's exactly what we're going to do today. So there is something called complementary. Two angles are complementary if the sum, the answer in addition of their angles, of their measurement, is 90 degrees. So for example, complementary angles are two angles that when added together will give me 90 degrees. That's basically what that means. Okay? So if I take this orange angle, which I know is 90 degrees, that's given to me, right? And I decomposed it into two smaller angles that add together to give me 90 degrees, I can basically take whatever angle x is and add it to angle y, whatever that is. I'm just using variables because I'm just making random things up. Whatever x is plus whatever y is will give me 90. So if I told you that angle x was 50, right? Well, that would mean that angle y would have to be 40 because 50 plus 40 gives me 90. You could use subtraction to figure that out. Do 90 minus 50, which will give me 40. It's kind of like what we did in the very beginning of the year, when we were using variables and we used the inverse operation to solve for it. So if I know that 50 plus y equals 90, then in order to solve for y, I would do 90 minus 50 equals y, which y would be 40. If I told you that angle x was 60, then angle y would have to be 30, because 60 plus 30 gives me 90, right? It depends on what's given to you. These are what we call complementary angles. They're two angles that have a sum of 90 degrees. When added together, they equal 90 degrees. Now, there's also another interesting vocabulary word, which is supplementary angles. Supplementary angles are angles that don't add together to give you 90 degrees. They have a sum of 180 degrees. So when you add those two angles, x and y, they equal 180 degrees. And the reason why that is because it's similar to what I had in that first example. This orange angle is straight. It's a straight angle. It measures exactly 180 degrees, going a half turn of a circle. So I can basically take whatever angle x is and take whatever angle y is, right? So here's angle x, here's angle y. If I add those two together, I will get 180 degrees. So let's say that I tell you that, hey, x equals 150 degrees. If I tell you that, you don't need a protractor. You could literally calculate what angle y is. You know that 150 then, I'm just replacing x plus y will give me 180 degrees. And so therefore, y would have to be equal to 30 degrees. Okay, so you can use your knowledge of math and how numbers work to help you calculate an unknown angle. That's what decomposing angles is all about, or additive angles is another way of saying it. Now, supplementary angles have a sum of 180 degrees. Complementary angles have a sum of 90 degrees. Both those words sound very similar. Complementary, supplementary. Mr. Hogan, how are we going to be able to tell the difference between those two? Well, you're in luck. I got a good way to remember. So everybody turn to page 17. If you are not already there, I think I told you that in the beginning of class to turn to it. But you will see, whoa, we're a little bit sidetracked here. There we go. You will see those big words up at the top. Complementary, supplementary. Two angles are complementary if the sum of their angle is 90 degrees. So in other words, if this is angle X right here, and this is angle Y right here, X plus Y would give us 90 degrees, right? This angle plus this angle would make a perfect right angle. Now, supplementary angles, X plus Y does not equal 90, it equals 180 degrees. So in other words, if this is angle X and this is angle Y, so here's X, here's Y. You notice how when you put those two together, you will get 180 degrees. So it depends on what you're talking about though. So if it's on a right angle, we're talking about complementary angles. If it's on a straight angle, we're talking about supplementary angles. So how do we tell the difference? Here's a little trick, and I want you to be, if you haven't written this down, obviously write this down, pause the video, and make sure you do that. But now, underneath complementary, I want you to write the letter C. C stands for complementary, of course. Watch my little trick here. I'm going to use another color to show you. You take a vertical line down, you kind of make a 9. And now that can help remind yourself that those angles, complementary angles, have a sum of 90 degrees. Okay, so see what I did? I could take my vertical line down and then oh yeah, that reminds me it's 90 degrees. Okay? Now let's take the letter S. Supplementary angles. How are we going to remind ourselves that supplementary have a sum of 180? Well, you can just remember, oh, well, it's not that one because I can't make 90 degrees with the letter S. Okay, but you could with the letter C. But here's another way that you can remember. Here's your letter S. Take your pencil and make a little diagonal line there. Now, if you notice, see how it's kind of like 180? It's like a little H right here. 180 degrees. Okay? So, again, take your letter C and S, and you're like, oh no, I can't remember. Which one's the one that has a sum of 90 degrees? Boom. C for complementary, 90 degrees. Supplementary, 180 degrees. See that? It'll help you remember. Trust me, I was taught this many, many years ago, and I remember it to this day. I teach it to kids every year, and they're like, oh, thank you so much for reminding me, because complementary, supplementary, they look so similar, and the only difference between them is the first three letters, com and sup. What's sup? Supplementary, right? So now let's go down to the bottom here. You'll see that there are some examples. I want us to write either C or S if we think they are complementary angles or we think that they're supplementary angles. Look at this diagram here. Do you notice how they're on a straight angle? That straight angle is angle, looks like NHF, okay? That could be decomposed into angle NHS with angle SHF. Those two angles would add together to give you 180 degrees, therefore they are supplementary angles. Sorry, I just realized that down on the bottom we're going to be answering stuff like this anyway. So yes, those are supplementary angles. It wants us to name two pairs of supplementary angles. So we're going to say, this is the symbol for angle. So angle NHS and angle SHF. Those are supplementary angles. Okay, so that's one pair of angles that are supplementary to each other. Now, if you look over here, you're going to see that this is also supplementary because they're on a straight angle. Okay, so if you look, this angle right here plus this angle right here equals 180 degrees. So we would say, well, the name of this angle, we would say angle DBR. Gosh, those are so blurry. I apologize. Angle DBR and angle, I notice it's RBX. Those are supplementary angles as well. So I apologize, we kind of jumped down to the bottom of the worksheet, but we're going to go back up to here. Name two straight angles. Well, one of the straight angles we've already talked about is this guy right here. Forms exactly 180 degrees. That'd be angle NHF. See if you can identify the name of this angle over here that is a straight angle. This would be angle DBX. Now, if you remember when we were naming angles in the beginning of our geometry unit, you can actually go in reverse and say angle XBD, or you can say like angle FHN. It doesn't really matter as long as the vertex is in the middle, right? So you can read from left to right, right to left, doesn't matter as long as the vertex is in the middle. You can't say like angle BDX. That's not how you connect the points, right? Or like, you know, like connect the dots or whatever when in those books and stuff, you got to go like D to B to X, right? I would not use a one letter to describe these angles at all, because if I say angle B, what am I talking about, right? You can only say angle B when there's only one angle, because then I can see, oh, you're talking about RBX, XBR, or angle B. But if there's two angles, are you talking about this guy here? Are you talking about the green one? Like, what one are we talking about? So you cannot just use one letter when there's multiple angles because it's too confusing. You need to use three letters. And obviously you can't use two letters because you can't make an angle with like angle RB. No, that's called, well, first of all, that's not even how you would name a ray, but this would be angle RBX, right? All right, now let's talk about complementary angles. So obviously if those two are supplementary because they're on a straight angle, look at this and see that, hey, these are right angles. Let's put those symbols in on these two angles. This one just happens to be upside down. So this is complementary and this is complementary as well. So if we were to name these two pairs of complementary angles, we could decompose this right angle right here into this guy, which would be CUZ, cuz, angle cuz. And then you have this angle right here. When you take the blue and the green that I'm writing right now, that would add together to give you 90 degrees. Those are complementary then. So we would say angle cuz and angle ZUP or ZUP. Angle ZUP. That's a great answer. Angle cuz and angle ZUP. Love it. Okay. Over here, we could decompose this right angle into two angles. This one here, we could say AYM, angle AYM. And what would be the other one? Well, we could say angle MYT. Those are complements to each other. Now notice how I just said the word complement. They complement each other. They go together. Supplement, they go together. Now if you're in science with me right now, we talked about dietary supplements yesterday. They go together, right? So supplement, these two angles go together. So if you are ever asked to name complementary angles, you're going to need to give me two angles, right? They go together. This angle and this angle are complementary to each other. They are complements of each other. and then supplementary need 2 angles as well. It just happened to be that they needed 2 pairs, so there's a pair, there's a pair, there's a pair, there's a pair. And no, I'm not talking about the fruit. All right, that's page 17. I know that was kind of a lot. Let's go back into my slides. So just as a review, this is my digital version of what I was showing you before. Complementary, supplementary. Remember, you can turn that C into a 90 or the S into 180 to help remind yourself. I've also told students that another way to remember is that the letter S, think of a straight angle for supplementary angles, right? It needs to be on a straight angle. Complementary are on a right angle. So if x equals 60 degrees, what's the value of y? I actually gave this to you at the beginning of class, so let's just see if you were paying attention. Well, we know if this is 60 degrees, that this must be 30 degrees right here, angle y, because 60 plus 30 gives you 90. If x equals 20, what's the value of y? So if right here is 20 degrees, again, I don't need a protractor. I could calculate 20 plus y equals 90 degrees. So what is y then? If you don't know off the top of your head, because it's just maybe you just need more practice with this, you can use the inverse operation and do 90 minus 20 equals 70 degrees. So y would be 70. This would be like the work that you would have on a test or an assessment, by the way, or in your practice problems. If y equals 35, what's the value of x? So if y equals 35, what's the value of x? Maybe grab your whiteboard, piece of paper. Don't try and do that all mentally in your head. You wouldn't believe the number of students who make silly, silly mistakes. I want you to get this right. What's the value of x? So you could do 90 minus 35 to help you figure out, minus 35 to help you figure out the value of x. So you ungroup. 10 ones minus 5 ones is 5. 8 tens minus 3 tens is 5. X has got to be 55 degrees then. What if I told you that angle y was 85? So angle y, notice how it's almost a right angle, right? So angle x plus 85 equals 90. So in order to solve for x, you do 90 minus 85. You're going to notice that angle x is extremely small. We would say angle x is only 5 degrees. Woo, that's really small, but that makes sense because look how small that turn is. Okay, let's go to page 18, do some practice ones. So they tell you the measurement of one of the parts that's already been decomposed, and your job is to figure out the value of angle x in each one of these examples. So I want to see work on this as well. So I don't want you to just do this all mentally. You can either write the equation or you can do the subtraction. What I mean by that is you can say, well, I know that x plus 30 equals 90 because these are all complementary angles. All of them will have a sum of 90. And you could do that as your equation and then tell me that x equals blah, blah, blah. Or what I want you to do is to do, or you can do both of these. To solve for x, you'd actually have to do the inverse operation. So you do 90 minus 30, which is 60 degrees. That's the value of x. Let's do number 2 together, and then you're going to work on the rest of page 18 on your own. So at number 2, we would say x plus 15 will give me 90 degrees. The sum would be 90. So in order to solve for x, again, do the subtraction. 90 minus 15 will tell you the value of x. Make sure you ungroup correctly. Should get 75 degrees. I want you to do 3 through 8, that's 6 problems on your own. I want you to have the equation and the subtraction, actually. I know that I said something a little bit differently before. I want to see that you understand how to do the equation and the subtraction to solve for x. I'll give you a bonus extra minute on that so that you can get both those things on each problem. You have 6 problems. I'll give you maybe like 3 minutes. That should be enough time. And you're doing 3 through 8 on page 18. Now 1 more minute. Seconds. All right, if you're not done, pause the video so you can finish. If not, let's just keep rolling. We're gonna go over the answers. Number 3, x plus 89 would equal 90, right? So 89 plus the value of x. Commuted property allows me to swap that around. You could have 89 plus x or x plus 89. To solve for x, you do 90 minus 89. That'd be 1 degree for x. Look how small he is. That's a cute little angle. Number 4, x plus 70 equals 90 degrees. 70 plus x, right? You can see that. 90 minus 70 will give you the value of x. Therefore, that is 20 degrees. Hopefully you're doing well so far. That's 2 problems. Number 5, 29 plus x will give me 90 degrees. Solve for x, I do subtraction, the inverse operation. 90 minus 29, do a little ungrouping here. Looks like it's going to be 61 degrees. Number 6, 35 degrees plus the value of x will give me 90, right? That's a perfect 90-degree angle. So 35 plus x equals 90 degrees. In order to solve for x, I use subtraction. 90 minus 35 equals, do a little bit of ungrouping. Looks like I'm at 55 degrees. And by the way, you should always double check that your answer even makes sense, right? So you can tell that angle x is bigger than angle the 35-degree angle. So if you're getting like 12, degrees, right? That makes no sense, right? That's way smaller than 35. So should be larger than 35. So 55 at least makes a little bit of sense. And what you can also do is, if you're really trying to double check your math, because addition and subtraction are inverse operations, you can literally do, well, let me double check. 55 plus 35, does that give me 90 degrees? Bada bing, bada boom. Yes, it does. I know I'm right, right? So you can literally just like ace worksheets because you know for a fact if you're right or wrong. All right, number 7. I know that angle 45 or 45 degree angle plus the measurement of angle x, so 45 plus x equals 90 degrees. They're complementary to each other, complements. I can do 90 minus 45. If I do that, I'm going to get 45 degrees, which again should make sense to you because half of a right angle is a 45 degree angle. If you remember, a right angle is a fourth of a turn. It's 1/4 of a circle. So if I cut a fourth in half, you get an eighth. And if you have been memorizing what you're supposed to be memorizing, an eighth of a circle is 45 degrees, right? 45 times 8 gives me 360. So, all right, number 8. 52 plus x equals 90 degrees. Well, solve for x. I do subtraction. 90 minus 52 looks like 38 degrees. Now, I will also tell you this. Remember I was saying before that obviously angle x is larger than 35. Sometimes they have worksheets, and I think this is an example of one of them. We might see something that says, not drawn to scale. What that basically means is, if you were to take a protractor and put it on top of these angles, they might not measure exactly 52 and 38. It might be something similar to what I do, where I just like draw out something on my whiteboard or whatever, and I'm like, okay, well, from here to here is 70 degrees. What is this? Well, do you think that's perfect? No, I didn't draw with a protractor to make sure that's exactly 70 degrees. But if they tell you that's 70, then this has to be 20. You can't argue and be like, well, Mr. Hogan, it really looks like it's a 45 degree angle, or it really looks like it's 30 degrees. Well, the math says otherwise, right? You can't just say, well, it looks like that, so I thought it was this. No, you have to use math. You can't just say, well, it looked like it was a 40 degree angle, so I said 40. Well, if you said 40 right here, last I checked, 52 plus 40 does not give me 90, so therefore it cannot be 40 degrees. I don't care if you think it is 40, it's not, right, based on the math. All right. Let's do some supplementary angles together now. So if I told you that angle x equals 150 degrees in this example, you could calculate the value of angle y, because 150 is this angle. Angle y is just a little bit more turn. So I could take 150 plus y equals 180, and I could actually do the subtraction. Instead of doing 90 minus whatever it is, I'm doing 180 minus whatever it is, because angle y has got to be 30 degrees then. If you're thinking it's complementary, you would obviously find yourself in an error right away. 90 minus 150? Well, you can't do that, right? Because that's a larger number that you're taking away. So this is definitely not complementary because it's not a right angle. It's a straight angle, straight supplementary, right? Okay, x equals 60 degrees. What's the value of y? So if this is 60, what's this? Well, 60 plus y gives me 180. Therefore, y would have to be 120 because 60 plus 120 gives me 180. If y equals 10, notice how I changed that up on you too. It's not saying x equals 10, y equals 10. Which obviously wouldn't even make sense that x would be 10 because x is obtuse. But y equals 10, what is x? Well, again, you could just do subtraction. 180 minus 10 give you 170 degrees. Notice how angle x is almost half of a circle. Right, so that makes sense, 170 degrees. What if angle y equals 82 degrees? So if this equals 82, notice how that's an acute angle. Angle x is an obtuse angle. So I know that x plus 82 will give me 180 degrees. So I can do 180 minus 82 to find the value of x. When I do that, I get 98 degrees. Which should make sense because 98 is obtuse, and that's what we were talking about. It's obtuse, and it's slightly obtuse, right? So here's my 90-degree mark that's squiggly that you shouldn't typically do. You should usually use a straight edge, but I can't use a straight edge on a computer because it's lame. Anyways, 98 plus 82 equals 180. So, okay, go to page 19. This is one of the last things that we're going to do together, and then we're going to actually talk about your independent work. So, page 19 is all supplementary angles, and supplementary all add together to give you 180 degrees as the sum. So, I'm going to do number 1 and 2 with you, and you are going to be doing 3 through 8. So, what I want us to do is similar to what we did on page 18, we're going to write the equation, and then we're going to use subtraction to solve for x in each one of these, okay? So, angle x plus angle, or 100 degrees would give me a straight angle, right? So we would say x plus 100 equals 180 degrees. So we solve for x by doing the inverse operation. 180 minus 100 equals 80 degrees. Should make sense because x is acute, right? It's slightly less than that 90-degree angle. Always good to ask yourself, does my answer make sense? You wouldn't believe the amount of times that that question could save you. Number 2, 76 degrees plus angle x will give me 180 degrees. So in order to solve for x, we do 180 minus 76. A little bit of ungrouping, nothing that you should be scared of because these numbers are small. 104 degrees. Huh, that's an obtuse angle measurement. Huh, angle x is obtuse. Huh, that makes sense. Huh, 104 degrees. Okay? All right, you know the drill. Equation and subtraction problem for each of these. 3 through 8. You're going to have 3 minutes. Go ahead and begin. I'll obviously go over them shortly. Don't feel like time is pressuring you. You can always pause the video if you need more time than 3 minutes. You can do it! Somebody just cheering for you. Don't be lazy. Equation and subtraction. You can do it. You can do it. Two more minutes. 1 minute remains. All right, if you're not done, go ahead, pause the video so that you can get done. I would rather you take your time doing what I asked, equation, subtraction. Make me proud by doing that than just continuing to just sit there and do nothing and then just watching me and copying down all the answers because you're not really going to learn anything by doing that. So let's go over the answers if you're ready for it. Number 3, 34 degrees plus angle x equals 180 degrees. Again, you could flip-flop those add-ins, right? That's called the commutative property. We love it. X plus 34 equals 180, doesn't really matter. 180 minus 34, though, is the only way to calculate x. So don't try and do that mentally. This is what I don't want you to try and do, and just do it all mentally in your head because there's easy errors to be made with ungrouping stuff. So you would get 146 degrees for angle x. Again, makes sense. It's an obtuse angle. Number 4, angle x, which I can already tell is acute, plus 125 equals 180 degrees. Solving for x, I do the inverse operation. 180 minus 125. Looks like I'm getting 55 degrees. Makes sense because at the beginning of the problem I said, hey, I think that's an acute angle, right? That's less than 90. Number 5, angle x, who's super small, he's probably acute angle, plus 163 equals 180. 180 minus 163 will help me figure out the angle x, which I think is going to be a very small degree measurement. Oh yeah, it is. 17 degrees. Very small, less than 90. Number 6, x plus 80 equals 180. Even if you can do that mentally, I don't care. 180 minus 80. I want to see the work. How did you solve for x? Well, you do that, that's 100 degrees. Makes sense because 100 plus 80 gives me 180. Angle x is an obtuse angle measurement, therefore angle x being 100 degrees should not be a shocker that it's greater than 90. Number 7, 48 degrees plus angle x equals 180 degrees because they're supplementary angles. 180 minus 48 will tell me the value of x. Looks like that's going to be 132 degrees for x. Makes sense, it's obtuse, right? Number 8, 107 degrees plus angle x equals 180. In order to solve for x, again, must subtract. Use the inverse operation of addition. I subtract, I get 73 degrees. Makes sense because it's an acute angle measurement. 107 plus 73, that does give me 180. I feel good about this. 3, 4, 5, 6, 7, 8. How'd you do? Hopefully pretty well. That's supplementary angles. The only difference between page 18 and page 19 is these have a sum of 90. These have a sum of 180. Because these are on right angles that measure 90 degrees. These are on straight angles that measure 180 degrees. See how it all makes sense in the end? All right. we're going to talk about your independent work, but before we get to that, your independent work is going to be, it might not be as easy as what we just did with the complementary and supplementary. Complementary and supplementary angles are wonderful because they can add to 90 degrees, like this guy right here. Boom, boom. Those are complementary. Forms a right angle. Okay? They could be supplementary, where you decompose a straight angle into boom, boom. That's nice. Because these have a sum of 90 degrees, these have a sum of 180 degrees. Okay? But what if I had an angle that was like this, that I wanted to decompose? Okay? So what if I told you that this entire angle was, I'm just making up a number, let's just say it's 140 degrees. Okay? I can decompose that angle too. I can decompose right angles, I can decompose straight angles, I can decompose this angle if I want to. I can decompose an obtuse angle if I want, I can decompose an acute angle if I want. The thing is, you have to be told some information though, that measures 140 degrees. And then you also have to be told some other pieces of information. Like, for example, if I say I decompose it into, this is 40 degrees, and I ask you, what's the measurement of this angle right here, angle X? Well, wouldn't you agree that angle X plus the 40 degrees is 140 degrees then, right? So angle X plus 40 equals 140 degrees. That's the sum. The sum is the entire angle itself. The addends are the decomposed, the smaller angles that add together to give you the larger angle. So always the entire angle will be the sum. The pieces or the parts that have been decomposed are the addends. So like X plus 40 equals 140. So then you would do 140 minus 40 equals 100 degrees. Making sense? So angle X would be 100 degrees. Now that's how you would do it on like an obtuse angle. I just want to show you really quick on an acute. And this is all going to play into your independent work. So I'm not just like wasting your time or whatever. Please pay attention to this part. So let's say here's an acute angle. Obviously it's less than 90 degrees. What if I said that this angle was 45 degrees? Okay, making kind of sense because it looks like about half of a right angle, but it's not drawn to scale. Ha! I can kind of use that statement and be like, haha, it's not drawn to scale. What if I decomposed it into two angles and said that this angle from here to here was 10 degrees? And then I was asking you, if I know that this entire angle, I'm going to move this entire angle is 45, then from here to here is angle X. Wouldn't you agree that these two pieces, when added together, X plus 10 will give me 45, right? So in order to solve for X, I would do 45 minus 10, and that would give me 35. Notice no protractor needed. I could figure out that this is 35 degrees. Same thing goes as if I told you the two pieces. I told you, hey, this is 35 and this is 10. Those are my addends. And I asked you, what's the value of the entire angle? Find the value of X. Well, you would have the addend plus addend equals the sum. Well, I don't know the sum, so I can calculate the sum. I don't need to use the inverse operation. I can just do 35 plus 10 and find out, hey, the sum is 45, or the entire angle is 45, right? So it depends on what pieces are given to you or what parts of the equation are given to you, but you're going to use the same sort of logic. Addend plus addend equals sum. Part plus part equals the total, right? So let's take a look at your independent work. You have a pixel art today for independent work. I think you're going to really like it. After you finish the pixel art, just verify that you have finished your 5 Dreambox lessons from this week. Remember, you're supposed to be working on them all week long. If you have not finished them, you need to finish them today. Okay, so your pixel art, I guess, won't take you forever in a day, but it will definitely take you some time. Then when you finish, make sure that you have finished your 5 Dreambox lessons as well. So here is your pixel art. It's got the little fish next to it because it's Friday. I only want you to turn this in when the full image is complete. Don't give me any garbage that's kind of like half complete, okay? I want the full image complete. The pixel art today, I did not create this one. I think it's really amazing though. I think you really like it. You might have to zoom out a little bit because at least for me, I'm like really zoomed in. It's a little bit hard for me to see. But if you zoom out, the numbers might be smaller to read. So you kind of have to balance a little bit, or you just scroll. Okay, so this section has to be completed is what I'm saying. So instead of using the letter X as their variable, they use the letter A. No big deal. It's just a variable, right? You can choose whatever the heck you want to do. So they're saying that the whole entire angle A is not given to you, but they give you the two parts, right? So they give you the two add-ins, 54 and 80. So on a whiteboard, I'm not going to have you submit your work, but you're going to have to figure out what the value of A is. So you're going to have to do, like, for example, on your whiteboard, you do something like this. 54 plus 80 equals A. So you solve for A by doing 54 plus 80. The whole entire angle, therefore, is 134 degrees. Okay, that's what you would say for A then. So I'm going to type in this box, 134. Notice, immediately, some pixels went into my image. If you don't see pixels immediately, it means you messed up. And sometimes that happens. Like if you were to say 124 instead of 134, not only is that not yellow, so you want to have a yellow background of the number that you just typed in, but you don't see any pixels. Okay, so you want to be able to see a yellow highlighted number and the pixels. Now, pay very close attention to where A is. So in this example, they tell you the whole angle is 135 and they give you only one of the parts and not the other. So like A plus 43 would give you 135. You have to use subtraction to solve for A. You're going to do, obviously, the first one I just kind of did with you. You have that one, 2, 3, 4, 5. It's just 5 more problems to do. So it will not take you eternity, but just notice very carefully where A is. And obviously, if it's not appearing in the pixel art, then that means you must have made a mistake. So take your time on that and make sure it's all correct before you turn it in. And like I said before, if you're all done with your Dreambox, then you are good to go. Just double check that you have everything done, like page 11 from Monday, your practice Google Slides for the Protractor on Tuesday, that you got a 70% or above on the Boom Deck, that you've done your Protractor quiz from yesterday, your Throwback Thursday number 6. Did you graph your score from yesterday, some of you? Not so sure if you did. Then your pixel arts, and then your 5 Dreambox lessons. I know that's a lot, but that's an entire week, right, of work. So make sure you're all good to go on that, so that when I return on Monday, I'm going to be like, yes, they did all their work. I'm so proud of them. Not the other way around. All right. Well, with that said, enjoy the rest of your Friday. Get that done. If you finish all of that early, then obviously you can do some Prodigy or whatever while you wait. Have a good rest of your Friday. Bye.